Okay, here's a video for the mass spring problem from today, part 2. We finished part 1 in class, so now we're going to do part 2 here. And the difference here is now we have some damping. And we're trying to find M, gamma, K, and the initial conditions. So let's do that. So the mass, it weighs 4 pounds. So we have mg equals 4. So m times 32 equals 4. So m equals 1/8. So there's m. And then we use this little formula to find K. So mg is 4. L is 2 inches, which is 1/6. So this says K equals 24. And then the last one says the mass is in the medium that exerts a viscous resistance of 6 pounds when the velocity is 3 feet. So we have this thing. This should be D equals minus gamma U prime. So we have 6 is equal to minus gamma times minus 3. So gamma equals 2. Okay. All right, the initial conditions say it's pulled down 6 inches. So that's down, it's in the positive. And then it's just let go. So that implies that the exit velocity is 0. So now our ODE turns out to be 1/8 U double prime plus 2 U prime plus, where's K? 24 U equals 0. U of 0 is a half. U prime of 0 is 0. Cool, multiply through by 8. So we have U double prime plus 16 U prime plus 192 U equals 0. And this gives us the characteristic equation. Complete the square. Half of 16 is 8. 8 squared is 64. So now we have r plus 8 squared equals 92 minus 128. So r plus 8 equals plus or minus I root 128. So r equals minus 8 plus or minus I root 128. Okay, we did the grubby work there. This is still W naught or omega naught. All right, let's write down the general solution. U sub t is C1 e to the minus 18 cosine omega naught t plus C2 sine, oops, hold on, forgot my e, C2 e to the minus 8t sine omega t. So there's the general solution. Let's invoke the initial conditions. That says 1/2 equals, the sine is 0, the e's go to 1, so that's equal to C1. So we rewrite it. Now we have U of t is 1/2. And I'm going to rewrite this like this. I'm going to factor the e to the minus 8t out. So now it's 1/2 cosine omega naught t plus C2 sine omega naught t, like that. This makes taking the derivative easier. So let's do that now. You take the derivative. So u prime is going to be minus 8e to the minus 8e times all this stuff. Plus e to the minus 18 times the derivative here, which is, what is that? It doesn't matter. Minus omega naught over 2 sine plus c2 omega naught cosine omega naught t. And 0 equals that. So that guy goes away, that guy goes away. So we have minus 4 plus C2 omega naught. So this says C2 is 4 over omega naught. Note that C1 and C2 are both positive. So when you take the tan inverse in a minute here, you can just read it right off the calculator. You don't have to do any kind of funny stuff. So let's do the particular solution now. It is, u sub t is e to the minus 8t. I got my C1 here. Plus 4 over omega naught. C2, these should all be omega naughts. Okay, there's the particular solution. What we're going to do is now simplify this guy just like we did before. So the amplitude on that piece, the sinusoidal piece, is the square root of C1 squared, which is 1/4, plus C2 squared, which is 16 over 128. And this is 32 plus 16 over 128. That's 48 over 128. And that goes all the way down to 16, 8, what is it, 3/8. Square root of 3/8, so that's R. That's your R. And now let's find delta. So delta is tan inverse of C2 over C1, which is tan inverse of 4 over omega naught over half. That's tan inverse of 8 over root 128. And from the calculator, this is 0.615. And so now we put down the final solution here. It is e to the minus 8t square root of 3 over 8 cosine 128t minus 0.615. Final answer.